Good morning, geometry class. Hope you guys are doing well. Today we are going to start on the next unit, but I tried to pick a unit that I thought remotely would be easier than maybe some of the other units. So if you talk to some of your friends, some of your friends are starting with circles, some are starting with surface area and volume. I'm choosing to do transformations. As I said, hopefully you'll find it on the lighter side as well. So today we're going to look at two types of transformations. One is a translation and one is a reflection. And then we'll look at the others next week, and then just a small quiz next Thursday or Wednesday, depending on what period I have you. And that will be it for this unit. So the other nice thing is it's really short as well. First thing I'm going to do is actually go to the IXL link, and you're supposed to do that as a warm-up. And it basically just goes through some of the basic types of transformations. And hopefully you did it before. If we have time, we'll look at it at the end. There are four types of transformations. One is called a translation. One is a reflection. One is a rotation. And the last one is a dilation. And on IXL, they use some basic words like flip or glide or move or stretch or shrink. Those are probably all words that you used when you first were introduced to these transformations way back when. Obviously, we're just giving them maybe a little bit more technical vocabulary. A transformation is a change in size, location, or orientation. And as I said, today we're just going to focus on the translation and the reflection. The translation, first of all, a little bit of vocabulary. The original figure is what we call the pre-image, and the resulting figure is called the image. And it is called an isometry, is a transformation in which the pre-image and the image are congruent. So if you think about all of these four up here, all of them are isometries except for the dilation, because certainly when we stretch or we shrink it, we're not maintaining the exact same size. So this is the only one that is not an isometry. Looking at the following, we just want to determine whether these are isometries. And certainly my graphics aren't great because I printed it out, but hopefully you can get a rough idea. This pair right here certainly looks as though it's an isometry because they're the exact same size. So I would say this one is yes. This one I think, and I could probably go either way on this one. I think this one is supposed to be a little bit smaller. So in this case, this one would not be. And certainly, as I said, the graphics on MathXL will be better than here. So if you take a look, they did, in this particular case, we went from NID to SUP. So this is the figure that we started with. This is called the pre-image. So we're going to put down triangle, NID, and the figure that we ended up with is called the image. And that was triangle SUP. So the first thing they want us to do is say, what does D, they call it map to. So in other words, it looks like in this particular case, I rotated it. When I rotate point D, they want me to figure out what does that correspond with here. Again, graphics aren't great, so we can always go back and rely on this statement here. D ends up being point P. If we take a look at SP, SP was here, which was the first and the third, and it corresponds with segment ND. So kind of like a congruent statement, we don't call it a congruent statement, but it's still a transformation statement that we're lining them up so the corresponding points and sides all match up. All right, so the first one we're going to look at is actually the reflection. The reflection is also known as a flip. And in all of our cases, we're just going to be flipping it over the x-axis and over the y-axis. The other thing I want you to notice is up in the example here, they use totally different letters, but if you notice here, we are using the same letters, but we're putting these little tick marks on them. So that way that we know that B corresponds with B prime, G corresponds with G prime, U corresponds with U prime. So we're not introducing a whole new letter. So the first thing they want us to do is reflect it over the y-axis. So here's your y-axis. And again, we want it the same shape and size. The other key thing is we're going to make sure it's the same distance from that axis as well. I'm going to pause and grab a marker real quick. So here is that y-axis, and I need to take those points and reflect it across. So if you take a look, A is 1 unit away. I'm going to go 1 unit away from here. I'm going to call this A prime. Okay, let's go take a look at point B. If you notice, point B is 3 units. So again, I'm going to count out 1, 2, and 3. We're going to label this to be B prime. And C is 1, 2, 3, 4, 5, 6, 7. So we can go 1, 2, 3, 4, 5, 6, and 7. We're going to label that to be C prime. Picture isn't great, but you kind of get the rough idea. What I also want you to notice is if you take a look at these points, and I think I better write it in a little bit different. If I take a look at point A was 1, 6, and when I reflected it, it became the point -1, 6. Let's take a look at another point, point B. We had the point 3, 1. If you notice, when I reflected it, it became the point -3, 1. And C, we've got 7, 2, ended up being -7, 2. So yes, you can do it graphically, or if you notice, there's something that we can see going on, and I'm going to write that in general. Take a look up here. If I have the point X, Y, notice my Y's didn't change, it was my X's that changed. So it would end up being -X, Y. Let's go take a look at a reflection over the x-axis. So again, let's go highlight that. We're going to take each one of those points. Again, we want to preserve the distance from that line. Looks like this point A is up 6 units. So I'm going to go down 6 units. Again, I'm labeling it A prime. There would be B prime and C prime. And again, going ahead and sketching it in. And similar to what we did over here, let's take a look at the points. The point 1, 6 ended up becoming the point 1, -6. Point B we had at 3, 1. That became a 3, -1. And then point C again, which was 7, 2, became the point 7, -2. So similar to what we did up here, we can actually write it as a rule. Notice when you're reflecting across the x-axis, you've got the point xy, then becomes x stays the same and y is the opposite. So those rules might come in handy if you're reflecting and you haven't been given the graph. All right, let's go take a look now at the translations. The translation is a transformation in which I'm not sure what I'm looking for there. Each point of a figure has the same length and in same angle measure. I'm going to say each coordinate. So the resulting figure after transformation is called the image of the original. That just kind of goes along with what we talked about on the front in terms of pre-image and image. So in this particular case, really a translation is what you are doing is just gliding it, or you are moving it. So in this particular case, they want us to take each point, they want us to go right 1 and up 4 units. So I'm going to start with this point at here. I'm going right 1 and up 1, 2, 3, 4. Again, I'm labeling it to be A prime. And the coordinates of that are 2, 1. Right 1, 1, 2, 3, and 4. So we've got the coordinates 4, 4. And for the last one, we're going right 1 and up 1, 2, 3, 4, and that is my point C, which would have the coordinates 5, 2. Let's go ahead and sketch that in. And again, this is considered an isometry because it's the exact same figure. It's congruent. Now, the other way we could do this is write it as a rule. We took each of our x's. If we went right 1, that means we added 1. If we went up 4, that means we added 4. And sometimes you'll also see it, and we'll get here in a second, write it as a vector. We could write this as 1, 4. So that means take each of these and add this vector to it. So if you take a look, if we added 1 to 1, we get 2. Negative 3 plus 4 is 1. Same thing here. You've got 3 plus 1 is 4. 0 plus 4 is 4. Okay, let's move on to the next one. So it says write a vector to express the rule. They want us to go up, right 5, and up 1. So as a vector, that would be 5, 1. If we wanted to write it as that algebraic form, that is x plus 5 and y plus 1. So we want to take each one of those and apply that same rule. So again, we can do it algebraically or we can do it graphically. Because I have the graph, I'm going to go with that. 1, 2, 3, 4, 5, up 1, and we can label that point to be A prime. 1, 2, 3, 4, 5, up 1, that is B prime. 1, 2, 3, 4, 5, up 1, D prime. 1, 2, 3, 4, 5, up 1, and C prime. And now we can go fill in those coordinates. So here we got A was 1, 2. B became the point 4, 2. C is the point 2, negative 1. And D is the point 1, negative 1. Sorry, it looks like that marker's bleeding through a little bit on there. Okay, the next one, they've been given with the rule. We just have to figure out which one this is. Well, first of all, if it's a -7, that means I know it would be going back to the left. So we know it's not this one, and we know it's not this one. If it's +4, that means we know it's going up, which would be here. So our answer is D. Okay, now in the next particular case, we've been given coordinates without the graph, and we have to translate the following. It says 5, negative 9. So what that means is we're taking each of our x's, we are adding 5, we're taking each of our y's, and we're subtracting 9. So if I take the first point, negative 8, and I add 5 to that, that becomes a negative 3. If I take 5 and I subtract 9, that is a negative 4. Let's go here. Negative 1 plus 5 is 4. Negative 2 minus 9 is negative 11. 4 plus 5 is 9, and 5 minus 9 is a negative 4. Let me give you one last case. Let's suppose it said, and just a totally separate question, if we had the point 1, 1, and it said when it was translated, it became the point 5, negative 2, and it said write the rule. So we're looking for algebraically, what are they doing? Well, they're going from 1 to 4, which means they are adding 3. They're going from 1 down to negative 2, which means they're taking those y's and subtracting 3. So written as a rule, we can write it like that. Written as a vector, we can write it as 3, negative 3. Okay, that's it for your notes. You do have a Math Excel. I think there's roughly 25 questions. Hopefully you're going to find this unit easy. As I said, that's why I picked it. Those questions are due by midnight tonight. So we're at 15 minutes right now. That Math Excel assignment, I wouldn't imagine, should take you more than 30. So that's your 45 minutes for today. Do not forget, you have the optional Unit 9 retake, which would be your checkpoint B, and that is due on Friday by 3 o'clock. Feel free to get online at any point or send me an email. I can get online with you via Zoom and answer any questions that you have. Thanks. You guys have a great day. Bye-bye.